did you say, Hallie, 21?
I just need to know it is like 28. Well, all the
28.
Because I'm getting like a huge number and I don't think it's right.
It's good.
No, I got in the thousands.
Did you want a type through or did you leave it in?
I have like for the hemisphere I have 3,456 pi.
The answer is 900.
Yeah. See, I looked and I was like, there's no way that I can.
All right, 28. So what we need to find, the solid is made up of the hemisphere, right cylinder, and right circular cone. All right, they want the surface area. So I need the surface area of, can I just put half a sphere here? So I need the surface area of half a sphere. What's that next part? I don't want the full surface area of a cylinder. What do I want?
You want this to be
Yep, just the label part of your soup can, which is the lateral surface area. And then I have to add to that the lateral surface area of a cone. And this one is the lateral surface area of the cylinder. Okay, so now we need to back up and say, what about formulas? What's the formula for surface area of a sphere? 4 pi r squared. But how much of it do we want? Only half. So we're going to divide by 2. What is the formula for surface area, lateral surface area of a cylinder? Right, it's the perimeter times the height, and the perimeter is circumference. So that's 2 pi r times the height. And what's the formula for lateral surface area of a cone? Pi r L, or pi r s. I think it's pi r L in this book, pi r s, 2 years ago in Algebra 2, which is dealing with that L or the S is your slant height. So as we go through and calculate then, 2 goes into 4 2 times, so I'm going to have 2 times pi times my radius, and what is the radius? 12 squared, plus, that should be 288 pi. Did you have 4 pi r cubed, or did you have 4/3 pi r cubed? Okay. So you get 288 pi. And then we have 2 times pi. The radius for that cylinder is still 12. And what's the height of that cylinder? 18. Okay, so go ahead and multiply that, and what do you get? 432 pi. Then we're going to have pi times the radius, which is 12, times the slant height. And they're nice. They give you the slant height. What is the slant height of your 15? So 12 times 15. What? 180. 180 pi. So now when you add them, 180 pi. So now when you add them together, well, you get 900 pi. 4, 5, 6, 7, 8, 90, 890, yep, 900. I tried adding from left to right instead of right. Units? Square meters, because we found surface area.
Oh, I actually need 24.
Yeah,
Okay, let's just go through
I
24.
went through and got the complete wrong answer, and I have no idea.
I think
24, so you have m plus n times the quantity m to the negative first plus n to the negative first, all raised to the negative first power. Okay, what they want us to do as we go through that, make it positive exponents. I'm just going to work inside the parentheses first, because if I can get this as one fraction, then that negative exponent just says take the reciprocal. So I'm going to work with the second set of parentheses, and I'm going to make them positive exponents, which is 1 over m plus 1 over n. So if I work inside the second set of parentheses, I get a common denominator. If I get that common denominator, it's going to be mn. So I'm going to get n plus m over nm. And that's raised to the negative first. But what's that negative exponent right there mean? Reciprocal. So then I have m plus n times nm over n plus m. So I can put the first fraction over 1. You can cancel m plus n, and you are left with nm. Sure. 27. The figures shown AD and CD are chords intersecting at P. Find the lengths of chords AD and CD. Okay. You might. Possibly.
I did remember like I did know.
Okay, so go back to here. They give you, this is 4x plus 3. This is 2x. We have 2x plus 3. And we have 2x minus 1. Now, not quite for sure if you remember the formula for solving it. But one thing you can do is you can make two triangles here. If you make those two triangles, what do you know about?
I added 2x to 2x plus 3. Does that not work?
I gotta get rid of that. I gotta come back to this.
And then I get like 4x plus 3.
As you come back to that, what do you know about these two angles right here? They're equal because they both open up to this arc right here. That's the same arc. So an inscribed angle is going to have half the measure of that arc. So these two are equal to each other. These are vertical angles, so they are equal to each other. So what do you know about your two triangles? They are congruent to each other. And if they are congruent, what do you know about corresponding parts? They will be, well, they are, I shouldn't say they are congruent triangles. They are similar triangles because two angles of one triangle equal two angles of another triangle. So the third angles are equal. If the angles are equal, they are similar to each other, which says the sides are proportional. If that scale factor is 1, then they would be equal to each other and congruent. But right now we just know that they are going to be similar to each other. So corresponding parts are going to be proportional. So set up your proportion. Maybe I'll ask you to set it up. Which way do you see your proportion? Corresponding parts have to be in the same position. Do you go one triangle to the other, or do you go, do you go corresponding parts, or do you go one triangle, the other triangle? Okay, so the one triangle, we have sides of 4x plus 3 over 2x. 4x plus 3 is right here. What corresponds to that in your other triangle? Yep, 4x plus 3 corresponds to 2x plus 3 in the right side triangle. 2x on the left-hand side triangle corresponds to 2x minus 1 on the right-hand side. So now you have a proportion, which is which one of you, I don't know, somebody mentioned that. Then I got a quadratic, right? So we set cross products equal. So I'm going to cross multiply. So I get 4x plus 3 times the quantity 4x plus 3 times the quantity 2x minus 1 And that's equal to 2x times the quantity 2x plus 3. So go ahead and FOIL. You get 8x squared. I guess I could just write it out. Minus 4x plus 6x minus 3 equals 4x squared plus 6x. Okay, say it 8x squared. I think most of you are just moving on solving right now, aren't you? I move them over to the other side. We get 4x squared. Would anybody factor that?
Yeah, and that's why I'm.
You what?
Oh, you could.
Am I correct? Does everybody have that value right there? 4x squared plus or minus 4x minus 3. Be nice if you could factor a 4 out, right? If you wanted to factor, let me just look for a second before I go to that link and then find out that it's some irrational number. Okay. You could factor. And if you want to factor, when you have a lead coefficient that is not 1, remember this could factor into 4x and x, or it could factor into 2x and 2x. Are the signs the same or different? Different. The signs are different. The factors of 3 are 3 and 1. And if we're going to factor where we have possible different sets, my thing is always go with the ones that are closer together first, because this number is not really large. If I had 3 and 1, can you see where that's going to give you a big value right there? Because you're going to have, you multiply the outer and the inner together, and that gives you 12 and 1, which does not have a difference of 4. I say difference because the signs are different. If I were to go back and switch those factors around, and I were to tell you it was 3 and 1, then the outer gives you 4x, and the inner gives you 3x. And if you put those together, the signs are different. You're either going to have 1 or negative 1x as that middle term, and that's not what we have. So that does not work for factoring. So I want to try this bottom. The factors are 3 and 1. If I multiply the outer together, I get 2x. If I multiply the inner together, I get 6x. The signs are, remember, we look right here, the signs are different. One has to be positive, one has to be negative. If negative 6x and positive 2x, when I group those together, I get negative 4x. Is that what I have right there? Yes. So I need to get a negative 6x to make that negative. The 3 has to be negative and the 1 has to be positive. And if you don't like that, go ahead and say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, you could do that as well. And you can use the quadratic formula to solve. If not, I have it factored. So in my factors, either to get 0, when you multiply the two numbers together, to get 0, one of them has to be 0. So 2x minus 3 equals 0. If that's the factor, you add 3 and you divide by 2. What happens if the other factor, you have 2x plus 1 equals 0, you're going to subtract 1 and divide by 2. So now I have solutions of 3/2 or negative 1/2. I think if you were to simplify over here, you should get, I don't think, if you simplify it, you should get the same answer. So I get 4 plus or minus the square root of 16 plus 48 all over 8. So you get 4 plus or minus the square root of 64 all over 8. So 64 has a value of, the square root of 64 is 8. So 4 plus 8 is 12 over 8. Or 4 minus 8 is negative 4 over 8. 12 eighths reduces down to 3 halves, and negative 4 eighths reduces down to negative 1 half. So the same values we got by factor. Now, what does the question ask you, though? Find the lengths of chords A, B, and C, D. So now I have to go clear back up to the top again. And if I look at chord AB, chord AB is going to be the length of, oh, I don't have it marked, AB. So chord AB, great, now I've got to go back and do this again. Okay, chord AB would be the length of 2x plus 2x plus 3. So it has a value of 4x plus 3, but what was x? Well, x was either negative 1 half or x was 3 halves. Is that correct? So I don't have to, I'll scroll. X was either negative 1 half or 3 halves. So what is 4 times negative 1 half? Negative 2 plus 3, which is 1. Or I come back over here and 2 goes into 4. 2 times 2 plus 3 is 6 plus 3, which is 9. I guess where I want to point it out to you is if I just look at this part right here, that 2x, that's a length of a segment, right? If x has to be, if it happens to be negative 1 half, what does this piece of segment become? Negative 1. Can that distance be negative 1? No. So what does that tell you about negative 1 half as a solution? It does not work. So we can rule out negative 1 half as a solution, not because it in itself is negative, but because when you are solving it, it becomes negative. So that rules this out as an answer. So therefore, AB has a length of 9. Do they give you units?
No.
Okay, we'll just leave it as 9. Then if I look at, what is it, CD? CD is the length of 4x plus 3 plus the segment 2x minus 1. I know that I'm not going to use negative 1 half. So if I group this together, I get 6x plus 2. And what is x? 3 halves. And when you solve that, 6 times 3 halves is 9 plus 2. So what is the length of CD? 11. So there's your answer.
This one's always confused.
Sure.
If you know where a bunch of those are, I would like to do them at some point.
Sure. You may have to remind me again, Jake,
Yeah,
because I will
also-
forget by the time that, let me see if I can't find it in IXL. I doubt if I can. I don't know. I'm sure I probably can find it. IXL has a lot of stuff in it. But, okay. On these problems, you just start at the very bottom. Start at the very bottom and work yourself up, and I can tell you you're going to do one of two things. You're either going to add fractions together, or you're going to divide them, which means you flip and multiply. So the first place we want to start, I'm going to highlight it. The first place you want to start is right here. So if I start at the very, very bottom, that's where I'm starting. And what do you need to do with that very bottom step? Get a common denominator. That common denominator is k. So I need it in the first term. So now I can write that as one fraction. So that means this is going to happen. I come over here and I'm going to recopy everything. I have 2 over 1 plus 3x over. Now I'm going to take this part that I've highlighted with the common denominator and write that as one fraction. So that's yk minus z over k. Okay? All right. Go there. So now what we need to do is look at, we're working with the bottom, working our way up. So get a common denominator, flip and multiply. Here's where we're at. So as we look at that, this piece right here, what if I flip and multiply that? So what I want to do is I want to take 3x, which would be over 1, and multiply that by k over, yk minus z. What do you get when you multiply those? 3xk over yk minus z. The k's do not cancel in y because it's not in z. It's not in all of the terms. So now if I do that, if I simplify what I highlighted in blue there, now I get this for my complex fraction. 2 over 1 plus 3xk over 3, not 3, over yk minus z. It's getting less complicated, right? Where do I want to focus now? In the denominator again. With the denominator, as I don't want that color, sorry. In the denominator, what do I do with that? Get a common denominator. So what is that common denominator? It is yk minus z. So I have to take this first term times yk minus z. Now it has a common denominator. Question? Keep going. Right, when you do that, now I have 2 over, if I write this as one fraction, you're going to have, sorry, I'm standing in your way, yk minus z plus 3xk over the common denominator of yk minus z. But now you have a complex fraction again, right? So you need to flip. I don't like it when I get the purple and the red together. You need to flip this denominator fraction and multiply it by 2. So when you get that, you get 2. Do I have to show it or can I just write it like this over that long denominator of yk minus z plus 3xk. Now you could multiply the numerator out if you wanted to, but in order to simplify it, we'd have to see if there's anything that would cancel, and to help with canceling, you factor. So leaving it in the factored form is fine. You notice that you don't have a y in every single term, there's not a z in every single term, there's not a k in every single term. Whole number values do not cancel. So there is your complex fraction simplified into one value.
I just want to know, number 12, which is what the answer for that.
What do you have?
I have, I think the element of the real such that x is greater than 2.
No, close.
Oh,